Hi, my name is Xiamen, and I'm a software engineer on WebSpatial.
My name is Roya. I'm product manager on WebSpatial. WebSpatial is designed for web developers. It is an open, involving web SDK designed for creating spatial apps using familiar development technologies like HTML, CSS, JS, React.
Now let's get to know more about it.
Let's see what we're going to cover in this video. First, we will dive into why you should build with WebSpatial. Next, we will break down the core features WebSpatial provides to streamline your development workflow. Then, my colleague Xiamen will lead a hands-on walkthrough to get you started using WebSpatial today, step by step. And finally, we will deep dive into specific WebSpatial features optimized for PICO OS 6, tailored to enhance your apps on our latest platform. Why WebSpatial? First, it's a fully cross-platform and based on current web open standards. Your app works as a normal 2D website on phones and laptops, and seamlessly unlocks spatial capability on any platform that supports unified rendering and shared space. Second, WebSpatial enhances existing web apps, bringing native-level spatial UI into web ecosystem. In PICO OS 6, it is install free and launches instantly with a URL, while still benefiting from all of the web's features. And most importantly, it's incredibly easy for developers. WebSpatial is designed for 2D GUI developers using a 2D content 3D approach. Developers can keep using their familiar tools, HTML, CSS, and JavaScript, without switching to professional 3D engine or learning a whole new tech stack. In short, if you can build a website, you can build a spatial app with WebSpatial. As you can see on the left side, it's a regular 2D website. This is how it appears today on a large screen or in a small browser window. Nothing changed here. WebSpatial does not break or replace the traditional web. Your site will continue to look exactly the same on laptop, phones, and normal browsers. But once the same website is opened on a spatial computing platform, WebSpatial can instantly enhance it into the experience on the right. And our cross-platform support is not just works on any platform that supports unified rendering and shared space. It means WebSpatial apps are still fully compatible with the 2D web ecosystem. WebSpatial is an open-source project that launched in 2025 May. We would like to show some demos from our developer community. This is a music player app with unique angular art. The animation is smooth. With WebSpatial, we can make native-like app but use familiar web technology. This is another demo made by Curie. They moved their existing e-commerce site to bring their store alive in a 3D environment using WebSpatial. On PICO OS, WebSpatial unlocks a full set of spatial features for the web. We support spatialized HTML elements, so developer can add material background, depth-based layout, and true spatial transforms. We also provide 3D content containers, both static and dynamic, allowing 3D elements to be embedded directly into web layouts. And with built-in spatial interactions and spatial scene support, web developers can create a native-level spatial experience with simple HTML and CSS. For spatialized HTML elements, WebSpatial lets developers break apart traditional 2D UI and lay it out freely in 3D space, making full use of the entire environment. With WebSpatial, HTML elements are no longer limited to just the X and Y axis. With depth layout, we can push elements forward into real 3D space, so parts of the page can float in front of the main surface. And with a material background, instead of using a flat, solid color, elements can have soft, semi-transparent background that react to the room around you. This makes the UI feel more nature and blended into the environment, just like a native spatial app. With just a few new CSS properties, like background material and z-axis value, you can turn any regular HTML element into a spatial UI element. No new tool, no new language, just a web you already know. With Spatial Transform, HTML elements are no longer stuck to the page. You can move, scale, and rotate them freely in front of a web plane in 3D space. Adding Spatial Transform is just a normal CSS. Here you can see we use Translate Z to push the element forward into 3D space and Rotate Y to turn it slightly. These are the same CSS transform property developers already know. So a few lines of code can turn a flat element into a spatial UI panel. Now, I will let Xiaoman introduce more features about WebSpatial and its specific capability in PICO OS 6.
Thank you, Roya. I will now cover the 3D APIs provided by WebSpatial. The model tag allows loading static 3D content from an asset file. The asset can be located relative to the local page or remotely hosted on the internet. WebSpatial supports both USDZ and GLB file formats on PICO OS 6, making it as easy as loading an image or video file. The 3D model can be interacted with by users, allowing them to rotate, zoom, and scale the 3D asset. The static 3D model allows developers to provide rich, interactive content with minimal development effort. The 3D model tag can also play a predefined animation that is part of the 3D model asset, allowing for an extra level of dynamism. The dynamic 3D API, which is exposed via the reality tag, allows 3D content to be entirely implemented in code. So it is dynamic and can be calculated in real time at runtime. Build complex 3D worlds using geometric primitives such as box, sphere, plane, cone, and cylinder. Attach complex 3D models loaded from the local file system or remotely from a URL. Build complex games and immersive 3D experiences using complex materials, remote 3D models, and attachments. 3D entities can be nested and combined into complex structures. Additionally, real-world physics interactions and particle effects can be added directly using JavaScript code. The physics engine can be enabled on an entity, automatically changing the transform properties of the entity based on physical conditions. WebSpatial provides high-level interaction events to allow developers to build great natural interaction experiences. Users can handle digital content like real objects, grab, drag, stretch, squeeze, and rotate it directly without special gestures or extra controls. High-level spatial events include spatial click, spatial drag, spatial rotate, and spatial magnify. A spatial scene is a content container, centrally managed by the OS. Every piece of app content must live in one or more scenes. There are three types of spatial scenes: window, stage, and volume. In a window scene, all content is positioned based on the window plane and can extend into the 3D space in front of it. A volume scene is a bounded local 3D space, a sort of 3D bounding box. It can also hold 3D content and 2D content. A stage has no boundaries and covers the entire full space. All three spatial scene types, while similar in nature, are treated differently by the operating system and provide different controls to the user. Developers can customize the position, size, and even background material of spatial scenes. Out of the box, WebSpatial supports three major platforms: PICO OS 6, Vision OS, and Android XR. In the future, additional platforms will be supported in order to provide a true cross-platform development environment. WebSpatial aims to provide the full power of the web with spatial 3D features across all platforms. WebSpatial strives to be open and standards compliant. On PICO OS 6, we support additional enhanced native features. For example, WebSpatial apps can be opened directly from the browser without any additional installation or configuration steps. With a single click, the WebSpatial app can be launched into spatial mode, allowing the user to experience full 3D interactivity. If the user wishes, they can install the WebSpatial app so that they can view it from their app library and easily return to it in the future. WebSpatial is built on top of React and allows you to use the full power of the ecosystem, including existing libraries, tools, and debugging experiences. WebSpatial seamlessly integrates with existing development environments and tools, including Vue.js, Next.js, RSPack, and RSBuild. Use the Pico emulator along with Chrome developer tools to test and debug your WebSpatial application. Note that WebSpatial applications are fully backwards compatible with the standard web, meaning that the same application will continue to work in mobile, desktop, and other web standard environments.